Hi, my name is Robert Engels, and on behalf of the SESM4 project, I would like to present one of the three technology primers that we have online in this project. There's one technology primer on RDF and OWL, presented by Chava Veres. There's one technology primer on linked open data, presented by David Noorheim. And there's one technology primer on SPARQL, which I will present now. So we have SPARQL and the RDF query language. But why do we have these? Well, if you look at the data sets that we had in the world, they were locally, they were containing local keys, they were not interconnected, the information in these data sets was not easily accessible from the outside, and we are gradually transforming into a world that is globally interconnected, showing a large global graph with unique identifiers that are actually linked to each other. Getting this graph means also that there is an enormous complexity in it, and browsing might not just be the best way to get to the knowledge that you need, so you need some kind of querying this graph, and that's where SPARQL comes in. So what is SPARQL? SPARQL is a specification by the W3C, World Wide Web Consortium. It's a query language for interlinked graphs that are presented in RDF and OWL. And the current version that is recommended by W3C is version 1.0 from 2008. Based on the experiences with the first version, the W3C working group on SPARQL is now actually quite close to recommending 1.1, which actually is an extension of this 1.0 with very useful constructs. We will show some of the examples later. So why do you want to use SPARQL? Obviously because you want to create this RDF and OWL data models and data sets. You will also want to use SPARQL to define globally unambiguous queries that you can actually use for distributed querying of data sets. And the last thing is that SPARQL is able to return results in formats that allow you to merge them automatically, which is also a very useful feature in your applications. So what can you do with SPARQL? What is in the syntax? There are 4 types of results in SPARQL. Describe, select, construct, and ask, which I will go through in this technology primer. In order to select sets, you can actually use operators that you know from SQL, like unions. You can filter with statements like not, and you can also post subqueries in the newer specifications of SPARQL. And there's a lot of arithmetic operators like count, average, and sum, but those are also part of SPARQL 1.1. So if you want to use those, you need the SPARQL endpoint that actually can interpret these operators. So let's go to the describe result type. Suppose you have a URI, you don't know what it is, and you want to know more about this URI. The easiest thing you can do with the SPARQL endpoint is just casting a describe to it with the URI that you have gotten. What you actually do is you give the SPARQL endpoint a node which you don't know anything about, and the SPARQL endpoint will return you the graph around it. It will give you the properties that are related to this node with some of the data related to that. So what you see here is that the node that I asked for is of a specific RDF type. Tells me that it is a project. So this node represents a project. It has a responsible organization represented by a URI. It has Dublin Core title attached to it. It has a project funder, which is a URI again, and it's got a Dublin Core abstract, which is a piece of text. So what I learned now is actually not only what this project is. It is a project with a specific title and organizations attached to it. But it also tells me something about the data model. So I got some insight in which types of relations are related to projects in this data set. Now what it does not do, the describe query, is actually give you the name of this organization, this URI here. So it doesn't hop further into the graph. The typical describe implementations that we've seen go just one hop and don't take the second step. So for that you have to define different type of queries or send iterative describe queries to the SPARQL endpoint. Now if we go to the next result type, which is select, we can, for example, select all the projects by this one responsible organization. So we got the URI of this one organization here, and now we want to select all the project ideas and project names that actually are of type project, which have a title, project name, and are executed by this responsible organization here. So graphically, what you do is actually you say, okay, I know a part of my graph, I know this one, this is a given, and I want to know all the instantiations of possible project ideas with titles related to this. In this case, that will be a table with 9 projects. We have 9 different project IDs with 9 project titles for this one organization. So that's what you can do with your select query. Now suppose that you're not very happy with this. This is a very general title here. You want to change that. So you want to say, okay, I don't want to have a double core title here. I want to replace it with something which is more to the point, more specified, which is actually a project title. Project title is defined in another ontology than you're using. It's not double core. So you want to replace that. You can do that with a construct query. So what you do then is you give your query a template with a new relation type. You select from your old graph the facts that you want to represent within this new graph, and you transform it. You construct a new graph and store that again. So then you have actually translated the title property. The last one is ask. What does the SPARQL ask do? Well, it is more or less a truth maintenance. So what you do here is actually you ask, are there any organizations that have a project attached to it? Is this true or false? Well, obviously we know it's true because we got 9 projects. So what you will get back here is a boolean true. So that's what you do with ask. Now, these are the 4 types of SPARQL queries that you can actually pose. Now you obviously want to try that yourself. The Session 4 project has some portals that you can use. On the one hand, we got the Computas LOT server, the linked open data server, with a lot of data sets from Session 4 and also external data sets that are not related to the project, which you can query. And we have a dedicated portal for the Research Council project data, which you can use for trying out. They are all accessible through the Session 4 project pages. So here you can try it out yourself. If you want to have some more further reading, you can of course go to the W3C organizations pages for the SPARQL 1.0 recommendation, or to the wiki for the W3C SPARQL working group. There are a few very good tutorials on the web. 2 ones that I took out is Hewlett Packard and Thales on these URIs. There's of course many more, but this is a good starting point for you. This technology primer was brought to you as part of the Session 4 project. You can go to the session4.net web pages to find the description of the project, resources for semantic technology. You can get descriptions of different demonstrators. You can watch them live at work. There are different movies on that web page. You can download software stacks for semantic technology. You can test out SPARQL endpoints. You can have a look at data sets, get some help with converting data sets, and much more. So have a look at the web pages and provide us feedback. Thanks.